Hello, welcome everyone. Today I am going to discuss refraction. But before dealing with refraction, first and foremost I am going to discuss about refractive index. So refractive index is defined as refractive index. It is of two types. One is absolute refractive index, and other one is relative refractive index. Absolute refractive index is defined as speed of light in vacuum divided by speed of light in a given medium. But relative refractive index is defined as, suppose this is a medium 1, this is medium 1 and this one is medium 2. Refractive index of medium 1 is mu1 and refractive index of medium 2 is mu2. So relative refractive index of medium 2 with respect to 1 is written as like this, and it is mu2 upon mu1. In absolute refractive index, we are observing that mu is inversely proportional to V. And for your information, I just want to tell you that if a ray goes from rarer to denser medium, then denser medium has greater refractive index as compared to rarer medium. So refractive index of denser medium is greater than refractive index of rarer medium. So of course, in denser medium, speed of light becomes less. So of course, velocity or speed in denser medium will be lesser than speed in rarer medium. Okay. mu1, this is refractive index of 2 with respect to 1. If I will write mu1 2, this is refractive index of 1 with respect to 2 upon 2. So mu21 is nothing but simply the ratio of absolute refractive index. Mu2 is C upon V2 and mu1 is C upon V1. So it comes out V1 upon V2. Whereas mu1 2, this is refractive index of 1 with respect to 2, and it is defined as the ratio of absolute refractive index of 1 to absolute refractive index of 2. This is ratio. So mu1 is C upon V1 and mu2 is C upon V2. So this is V2 upon V1. So refractive index, one is absolute refractive index. It is defined as speed of light in vacuum upon speed of light in a given medium. This is speed of light. Speed of light in vacuum, and this one is speed of light in the given medium. Okay, now if I will write mu21 into mu12, this is refractive index, this is relative refractive index, this is refractive index of medium 2 with respect to medium 1. and this one is refractive index of medium 1 with respect to medium 2. So this is mu 2 upon mu 1 and this is mu 1 upon mu 2. So this comes out what? 1. Okay. Some important points. Suppose light rays goes from glass to water. This is glass and there is an interface which is distinguishing the medium, and this one is water. Refractive index of glass is greater than refractive index of water. Okay. So glass is said to be denser medium as its refractive index is more, and water is said to be what? Rarer medium. In denser medium, speed of light is less. So of course, speed of light in glass will be lesser than speed of light in water. If we will write refractive index of glass with respect to water, this will comes out mu g upon mu w. And if we will write refractive index of water with respect to glass, this will turns out mu w upon mu g. Okay. As far as dependence of refractive index is concerned, so refractive index depends on the nature of the medium as well as wavelength and temperature. Okay. There is a relation known as Cauchy relation. According to Cauchy relation, mu is equal to A plus B upon lambda square plus C upon lambda 4. So far you have understood that mu, this is absolute refractive index and this is C upon V. So mu is of course inversely proportional to what? V. So mu 1 upon mu 2 is equal to 1 upon V1 upon 1 upon V2, and this will become V2 upon V1, which suggests that mu is of course inversely proportional to speed, and this relation suggests that mu is inversely proportional to lambda and inversely proportional to V. This is from here and this one from here. So suppose we are writing mu g, mu glass upon mu water. Okay. So this will comes out lambda water upon lambda glass, and this will comes out speed in water upon speed in glass. Okay. And this is what? Mu g w. So once again I want to tell you that refractive index depends on wavelength, refractive index depends on the nature of the medium, and refractive index depends on the temperature of the medium. Okay. Now I am going to deal with laws of refraction. Laws of refraction. Laws of refraction states that first and foremost, what is refraction? In reflection, we have studied that bouncing back of the light rays in the same medium. but in diffraction light rays pass from one medium to another medium. This is normal. This one is incident ray. And this one is refracted ray. Of course, this is what? Normal. I is angle of incidence. This is angle of incidence, and R is angle of refraction. Angle of refraction. So laws of refraction states that first, incident ray, refracted ray, and normal all lie in same plane. All lie in same plane, or we say that they are coplanar. Coplanar. Okay. Second, suppose this one is first medium, this is first medium, and this one is second medium. So its refractive index is mu1 and its refractive index is mu2. So the product of refractive index and the sine value of the theta of that angle, that medium, is always constant. That is mu1 sin I is equal to mu2 sin R, and this is equal to mu n psi, this is equal to mu3 sin R dash. Suppose there could be any other medium, and this is equal to what? Constant. Now I am going to discuss with bending of rays. We have already mentioned there are two mediums. One is rarer medium and other one is denser medium. A rarer medium is that medium whose refractive index is less, and denser medium is that medium whose refractive index is more. So now we are going to deal with bending of rays. Case 1. When light ray traveling from rarer medium to denser medium, rarer medium to denser medium. Suppose refractive index of denser medium is mu d and refractive index of rarer medium is mu r. Since it is denser, so of course refractive index of denser medium will be greater, and speed of light in denser medium will be lesser as compared to speed of light in rarer medium. Here is a case, here is an interface. This is denser medium. Suppose this one is rarer medium and this one is denser medium. Refractive index of rarer medium is mu r and refractive index of denser medium is mu d. This is incoming ray, incident ray. This is angle of incidence, and this one is refracted ray. This is refracted ray, this one is incident ray, and this is what? Normal. Okay, this is angle of incidence and this one is angle of refraction. So from Snell's law, from what is Snell's law? Snell's law, mu I sin I, mu1 sin I is equal to mu2 sin R, and this is equal to what? Constant. We are applying Snell's law for these mediums. So in this medium refractive index is mu R and angle is I. In this medium refractive index is mu D and angle is R. So mu R sin I is equal to mu D sin R. So from here sin I upon sin R. Snell's law is also stated as the ratio of sin value of corresponding angle remains constant. This is equal to mu D upon mu R. And we know that refractive index of denser medium is more as compared to refractive index of rarer medium. So of course this will be greater than 1, which states that sin I is greater than sin R. That states that, which implies that I is greater than R. That is, when light rays traveling from rarer to denser medium, this is a rarer medium and this one is denser medium, R is less as compared to I. So we say that when light rays traveling from rarer to denser medium, rays bend towards normal. Okay, because the original direction was this and it get bent, so it bent towards normal. Second is, when light rays travel from denser towards rarer. Second case is when light ray is traveling from denser medium into denser medium to rarer medium. Again, this is an interface which is separating two medium. This is a rarer medium and this one is denser medium. Now I am sending light from denser into rarer medium. Now this is I and this is R, because light is going from denser to rarer medium. Refractive index of rarer medium is mu R and refractive index of denser medium is mu D. Again from Snell's law, mu D sin I is equal to mu R sin R. So from here we can write sin I upon sin R, and this is equal to mu r upon mu d. And we know that refractive index of rarer medium is lesser than refractive index of denser medium. So denominator is greater than numerator. Of course, the fraction will comes out less than 1. That is sin I is less than sin r, and we suggest that I is less than r. When we observe it carefully, we can conclude that when light rays travels from denser medium to rarer medium, it bends away from normal, because the initial direction was this and it bent away from normal because this is normal. So this is basic stuff which we have to hold in our brain. Thank you so much to all of you.